Next, a comprehension type, paragraph type. A problem is asked. He considers a compound A. In this compound, according to the statement, nickel, carbon and oxygen are present. It contains 34.38% nickel, 37.52% oxygen and the rest carbon. That means you add these two percentages and subtract that total from 100, which will give you the percentage of carbon. All right. From this, it is possible for us to arrive at an empirical formula for that particular compound A. That is the first question. What is the find the empirical formula of A. All right. Some more points about compound A are given. This compound is diamagnetic. All right. This compound contains metal nickel because he says it contains nickel, carbon and oxygen. So the central metal atom is nickel. It forms a double salt. It forms a double salt with ammonium ion and sulfate radical. All right. A, some more points about this compound A. A is volatile and poisonous. You see, if it is said that a compound is volatile and poisonous, there are cases in which these are some specific points from which we can have an idea about the original compound A. All right. This compound A is purified by distillation followed by decomposition. All right. Bearing all these points in mind, let us try to work out this particular problem. From the given data, you are asked to find out the empirical formula of the compound A. Now, let us see. Percentage of nickel is given as 34.38. Percentage of oxygen given as 37.52. Add these two and subtract from 100, you will get 28.10 as the percentage of carbon. So it is obvious from the first statement, since the compound contains nickel, carbon and oxygen and no other element, it is obvious if you add these three percentages, it should work out to 100. That should be. So 34.38% nickel, 37.52% oxygen and the remaining 28.10 is the percentage of carbon. Now in order to arrive at the empirical formula, divide these percentages by the corresponding atomic weight or atomic mass. Atomic mass of nickel is given as 58.7. So the percentage of nickel divided by the corresponding atomic mass works out to a value of 0.5856. Similarly, percentage of oxygen 37.52 is divided by 16 atomic mass of oxygen and this works out to 2.345. The remaining percentage 28.10 is divided by 12, the atomic mass of carbon. This works out to again 2.342, which is more or less the same as 2.345. So you get three values, 0.5856, 2.345 and 2.342 as the values for nickel, oxygen and carbon. Of these three numbers, the smallest is 0.5856. So divide these three values. The three values are 0.5856, 2.345 and 2.342. These three values are divided by the smallest number, namely 0.5856. If you divide this by the same number, the value will be 1. And 2.345 divided by 0.5856, that will work out to 4. Similarly, 2.342 divided by 0.5856 will also work out to 4. That means for nickel 1, carbon 4, oxygen 4. So in the compound A, the ratio in which these three are present, nickel, carbon and oxygen, will be 1:4:4. That means for every nickel atom there will be 4 atoms of carbon and 4 atoms of oxygen. Or in other words, we can say like this: NiCO 4 times. You can notice this formula gives for every nickel atom 4 carbon atoms and 4 oxygen atoms are present. Carbon and oxygen are in the form of carbon monoxide, and so we can write the empirical formula of the compound A as nickel, that is NiCO 4 times, which is known as nickel tetracarbonyl. And probably you remember organometallic compounds. And one of the examples of organometallic compounds is metal carbonyls. Of course, what is an organometallic compound? An organic metallic compound is one in which there is a metal carbon bond. So those compounds in which we have metal carbon bond, these are in general known as organometallic compounds, and metal carbonyls are examples of organometallic compounds. And another interesting point in this connection with metal carbonyls I want to mention, namely in metal carbonyls the central metal atom is in its zero oxidation state. For example, in nickel tetracarbonyl, nickel is in its metallic state, zero oxidation state. So for A, find the empirical formula of the compound A. The empirical formula is nickel tetracarbonyl NiCO 4 times. Metal carbonyls, especially this nickel tetracarbonyl, is purified by a method, and this information is given here. A is in question. A is purified by distillation and decomposition. Now the salient feature here is this sentence: A is purified by distillation and decomposition. This is the method of getting pure nickel. Now interesting point and important aspect is also given here, namely what we have to arrive at is at a comparatively low temperature nickel combines with carbon monoxide forming nickel tetracarbonyl. At a comparatively low temperature nickel tetracarbonyl formation takes place. You collect, this is volatile, A is volatile, you collect it and increase the temperature. On increasing the temperature, the compound undergoes decomposition. So, we usually write Ni plus 4CO low temperature, but this reaction you can reverse at a high temperature, decomposition takes place. And this particular reaction is very important because whenever nickel ore is present, cobalt is also present along with it. So this is a method of separating nickel from cobalt. And this process is the famous process given by the scientist Mond. So this method of formation of nickel tetracarbonyl at a comparatively low temperature and increasing the temperature leading to decomposition, this is the principle of the Mond's process for the purification of nickel. So we have arrived at the empirical formula to be NiCO 4 times, and of course this Mond's process, this is the answer for subdivision D. Question subdivision D. What is the purification process? This purification process is known as the Mond's process after the scientist Mond, who tried to separate nickel from cobalt. All right. Why is it diamagnetic? Now again I want you to remember one point here. Any complex in which there are certain number of unpaired electrons, even one unpaired electron, that is known as paramagnetic in nature. Even if one unpaired electron is present, it is said to be paramagnetic. But if in the complex all the electrons are paired, that means there is not even a single unpaired electron, that complex is said to be diamagnetic in nature. Now this question is, why is it diamagnetic? That means nickel tetracarbonyl is diamagnetic. That means no unpaired electron is present. Now in this connection, you remember one point I have mentioned earlier, namely in metal carbonyls, the central metal atom is in its zero oxidation state. So in nickel tetracarbonyl, nickel is in the metallic state, zero oxidation state. It is not in the form of its usual +2 oxidation state. In this connection, I want to mention another point. There is one rule which is often asked: effective atomic number rule, EAN rule. According to this, nickel atomic number 28. Now in complexes, each ligand contributes 2 electrons. So nickel 28 electrons, from 4 carbon monoxide molecules, 4 into 2, 8, 28 plus 8, 36. 36 is the atomic number of a noble gas. So in complexes, this effective atomic number rule is obeyed in several cases. That is, the number of electrons contributed by the metal atom or ion, as the case may be, plus the total number of electrons contributed from all the ligands. If this total works out to a number which is the atomic number of a noble gas, that is known as the effective atomic number rule, and this rule is obeyed in the case of nickel tetracarbonyl. And why is it diamagnetic? Nickel tetracarbonyl is said to have a tetrahedral shape. Tetrahedral shape means sp3 hybridization. That means the electrons present in the d orbital, these get paired and no unpaired electrons, and so it is diamagnetic. See, it forms a double salt. Nickel forms a double salt with ammonium and sulfate ion. The double salt is nickel ammonium sulfate, which has the formula NiSO4 NH4 twice SO4 6H2O. I think you remember the difference between a double salt and a complex ion. That is, in solution complexes will have a complex species, not single metallic ion, etc. But double salt will ionize in solution. It will not retain its identity in solution. So if a passage is given, a paragraph is given, questions like this may be asked. Do you follow?